Hi, so going over your transformations, if you're adding or subtracting something on the outside of an equation, it is either going to go up or down based on if you are adding or subtracting. Now, see how this is, let's go. See how this is on the outside? If you are on the inside of parentheses, that's going to be counterintuitive. You're going left or right, but you do the opposite. So if I have a plus k, I would actually go left by k. And because it's on the inside and it's negative, I'm going to do the opposite and go to the right by k. So for example, if you were to have an equation, y equals, let's see, x plus 2 squared minus 5. Because it's inside parentheses, that is going to be to the left by 2. And because it's on the outside of parentheses, it is going to be down by 5. And this is important for us to remember for the quiz tomorrow. You're going to be given an equation, and you have to tell me which direction is it going in. Now, if you have a negative, that's either a reflection up or down, or a reflection left or right. So this is a reflection over your x-axis when the negative is out front. What that means is that it's going to reflect it up or down. If you have the negative on the inside, that's going to be a reflection, but this time over your y-axis. So instead, this is going to be reflecting left or right. The last thing we have to go over is if you're multiplying by something. If you multiply by 2, then you are doubling the size of it. So this is called a stretch by k. It is a stretch when, let's pretend that's a stretch. It's a stretch when k is greater than 1, or you are a compression when k is less than 1, but also greater than 0. So a compression is just shrinking, right? Like if you multiply by a half, then you are going to get half as large, and that's called a compression, shrinking it. Now, we do need to know what your average rate of change is. Your average rate of change is the same thing as your slope. A slope, or rather the average slope between any two given points. Anytime it says average rate of change, you are going to go and use y2 minus y1 over x2 minus x1. And that formula is important to know tomorrow. Now, when they tell you to find the average rate of change, they will always give you an interval. Usually they will say it like this, like from x1 to x2. Now, if they give you an equation, you have to put the equation in the calculator, and you have to find, go to the table and find the coordinates to actually do it with. Sometimes they give it to you in a graph where your 2 points will be your x1, y1, x2, x2. And sometimes they give it to you in a table already, which is really nice. Now, you do need to remember that if you're asked to interpret the average rate of change, usually they'll say explain. You have to write a full sentence, and you have to talk about what's actually happening in the problem. So if we're talking about the change in temperature and the average rate of change is 2, you need to say that on average, the temperature is increasing by 2 degrees per month, or whatever we happen to be talking about. But you can't just say mathematical things. You have to relate what the problem is actually talking about. And when they say this, you want to start all of your explanations off by saying on average, because we don't know what's legitimately happening, but the average rate of change is an estimate. It's an average value. It's not exact. So they might ask you to find the average rate of change of y equals 2x plus 1 on the interval from 1 to 3. Now, these are your x values, x1 and x2. What you would have to do is put the equation in your calculator and then go to 1 and 3. Now let's see, that would be 3 and 7. You're going to now do y2 minus y1 over x2 minus x1. So 7 minus 3 over 3 minus 1. And you would get that the average rate of change, if you were to put this in the calculator, is 2. And the positive 2 means that you are increasing. If our answer was negative 2, it would mean that the graph was decreasing at that value. Going on to inverses of functions, the symbol for inverse is this. It has a little negative 1 as an exponent. We call that f inverse. Okie dokie. So in inverses, the domain and range are switched. Algebraically, you switch x and y and solve for y. So if you had y equals 2x plus 3, and if you wanted to find the inverse, we would go with x equals 2y plus 3. I switched my x and y's. You are going to have to then solve for y. So I would subtract 3 on both sides, and I would divide by 2. And you would end up with y equals x minus 3 over 2. And there are a lot of different ways that you could write this. This is just one variation of the answer. What is important is that because now it's an inverse, you put the little negative 1. I didn't write f inverse because the equation started with y, not f. So we do need to know this. You switch x and y and solve for y when they ask you to find an inverse. Now, there is a calculator trick. So if you wanted to find an inverse, if you put this in the calculator, let's see, we would get a table and you would get several values. So let's see, we would get 0, 3, 1, 5, 2, 7, I believe. Now, this is the original. This is y. This is y inverse. Your inverse equation is just going to have flipped values. So in order to find an inverse, you just switch the coordinates. So if you have 0, 3, the inverse coordinate is 3, 0. And I'm going to say that's important for you guys to remember as well. So we have 3, 0, we have 5, 1, and instead of 2, 7, now we have 7, 2. So if you put this in the calculator, you would be able to check your work because you'll see that they have your inverse and your inverse table have the same coordinates. So this is a really great multiple choice strategy if you don't know how to find the inverse. Create the table of values, switch them, and your proper answer, the inverse, has those new table of values that you're looking for. For regressions, in your calculator, you're going to go to Stat, Edit, and you're going to input your L1 and your L2. You need to make sure that none of your lists are deleted. If there's no L2 or no L1, you have to go and clear it. You have to go and reset your calculator. But let's say that you did have a list that you want to get rid of. You're going to highlight the list, hit clear, enter. And that's how we get rid of it. So once you hit stat edit, you're going to hit stat calculate, and you're going to find the proper regression based on what the question says. They'll usually tell you to do an exponential regression or a logarithm. Sorry, a log regression. So an exponential regression is choice 0, and if you want a log regression, you have to do choice 9, ln. What you don't want to do is logistic. Logistic is not the same thing as a log equation. So if I do an exponential regression, all you have to do is keep hitting, there we go, keep hitting enter. And what's really important is that you actually write down these values for your on your free response. You want to write every single thing down, exactly what you see here from the calculator. The reason is it's going to get you partial credit in case you mess up. And 1 point is better than 0 points, for sure, 100%. So These are the ones we mainly use for logs and exponential. And what's important are the steps on your calculator. You need to know that to get to the list, you have to hit stat edit. And then to get to create the regression, you have to hit stat calc. So knowing that regressions are in the stat section of your calculator, super important. Regression models to know this is a linear regression, an exponential, quadratic, because it looks like a parabola. This is a log regression, or LN. Remember, LN is a log with a base E. And this one, it actually looks like a trig function, right? Yeah, maybe. It starts at the max, so this is actually cosine, not that you need to know that, but it would be a trig regression, which your calculator says is SINREG for trig. Last thing we're going to cover is even and odd functions. That is different than even and odd degree. Even and odd degrees have to do with the largest exponent, but even and odd functions have to do with symmetry. So graphically, even functions are symmetrical over the y-axis. The trick for them is that you can fold in half. Now that is never an explanation you would write on the regions. You would say it's symmetrical over the y-axis. However, I can take the y-axis and I can fold it in half. The left looks like the right. Now, odd functions are symmetrical about the origin. That's a little bit more difficult to see. So here we go. A trick for it, although you have to actually mathematically say it is symmetric about the origin, for an odd function, you could turn it upside down and see how you see the exact same graph? That makes it odd. So if you turn something upside down and you see the same graph, then it is an odd function. If you could fold it in half down the middle, not down anywhere, but down the y-axis, then it would be even. And this is important to know, the different type of symmetry for your quiz. Although for some reason, what's happening? Go away. Huh. Okay, I got it to work. Knowing the symmetry for even and odd functions is important to know for tomorrow, and